In this chapter, we'll be using Pina to do state management in our application. Up until now, we've been using local storage to save the course progress of the user as they go through our course. But we'll be refactoring that to use Pina instead as a state management tool. We'll also be adding a model to our database so that we can track that progress in Supabase. At the very end, we'll also add in a feature to see the course completion percentage in the UI. In this lesson, we will be setting up our Pina store so that we can get the course progress in the Pina store instead of in our local storage. We'll also, later on in this chapter, move the course progress into the database so that we can actually keep track of it in a good way as opposed to just relying on local storage. Now, the course progress state is fairly simple, so if this is all your application was doing, you could keep it in just some well-written composables. But we will be using Pina in order to showcase how Pina would work with Nuxt. And one of the benefits of using Pina is that you get a really good integration with the dev tools. And so you can see that working. So the first step is to install Pina. And Pina comes with a Nuxt module as well. So we'll install all of that together. The next step is to register the Pina module in our Nuxt config. There we go. And we will be adding a store in the stores folder. So we'll just create that for ourselves first. Then we'll create a full file called courseprogress.ts. And our course progress Pina store will first look like this. So in Pina, there are two different ways of defining stores. The first is the options store, which looks a lot like the options API and is very similar to the Vuex API. The other syntax is the setup store, which reflects the composition API. It's very similar to and almost exactly the same as just writing your composables in a setup function on your component. So it feels like you're just writing a component that has no rendering. And so I prefer this because it keeps that consistency between your Vue components and the Pina store because they are written in exactly the same way. So what we're doing here is first we have to pass in a key to describe this store, similar to how we provide a key to use state. And then we have this progress, which we're going to initialize from our local storage. Then we're going to have a ref to keep track of whether or not we've initialized this store. And then we have this initialize function. What we're going to do is first check to see if the store has been initialized. And if it has, we're going to exit early. But if not, we're going to continue on. And so the reason that we have this initialize function is that we cannot have our setup here be async. Yet, we need to use data that is async. We need to get data from our endpoints later on that will be async. And so we have to put that in a method that's async. And so to get around that is we just put it inside of an action. And then when we call this action, it will load up the data that we need to initialize the store. But for right now, this method doesn't really do anything. And all that we're doing is moving the progress from the lesson component and into the store. We also need a way to toggle the progress of our lesson. This toggle complete method is a stub method, which we will expand on once we get our endpoints going. But for now, all it does is it takes in the chapter and lesson slug. If there's no user, there's no progress that we can update on the backend, so we return early. And then what we do is we first grab the current progress, and then we set that progress to be the opposite. So in this way, we're able to toggle the value. But right now, we're only doing this in the client and not updating anything in the backend. That will come later on in this chapter. Once we've added in this action, we need to then export it so we can use it elsewhere. And one thing that we're doing here is we're optimistically updating the UI. So this is a common pattern, especially if you have a slow backend. This is commonly done on mobile devices, which are usually subject to slower cellular networks. But what we do is instead of waiting for the backend to tell us that what we've done is successful, we just first assume that it will work. And if it doesn't work, then we backtrack because 99% of the time it will work successfully. So we should just assume that it always will. And then in those 1% or less of cases where we actually weren't able to update the progress, then we'll just backtrack. So this makes our UI much snappier and faster than if we were just always waiting for that slow network request. So I wanted to throw that in there just so you can see this pattern here. Another thing that I like to do is to provide really good defaults to different methods and composables that we're using. And so in our case, we always have to pass in the chapter and the lesson, but it's a pretty good assumption that we just want to default to whatever we're on currently, whichever lesson, whichever chapter we're currently looking at. So we'll add this code in here to automatically default to that. If one of these is missing, we will grab the corresponding one from the route so that we can fall back on the current lesson that we are using. So now we've got a pretty good store going. We're grabbing the progress from local storage. And then we've got this toggle complete button that lets us toggle the progress. So far, what we're doing is just refactoring the functionality that we already have and moving it into this Pinia store. So now we need to go and actually use this store. So we'll go to our lesson slug component here. We'll need to import from our store. Then we'll need to initialize that store by calling use course progress. And then because all that we're using here right now is these methods, we can destructure off of this store. With Pinia, we have to be careful that we're not destructuring the refs off of this object because if we do that, we will lose reactivity. We'll also initialize the store by calling initialize here. And we only need to initialize this in one component. But because we've added in that check, it doesn't matter if we call this initialize in multiple components by accident because we have that safeguard. The other thing that I'm going to add is an isCompleted computed prop. And this one will look at the store progress and see if our current lesson is completed or not. And that's what we will be using in the lesson. So now we need to update the template to reflect these changes. And our model value is completed. And our function here, toggle complete, is the same. But we also need to remove all of that existing stuff so we can get rid of everything here. You may have noticed that prior we were using an array to keep track of our progress. But in this store here, we've switched to an object, and we've switched to using the actual slugs for the chapter and the lesson, and not the number for the lesson, not the index. I've refactored this data structure in this way because it's a lot easier to keep track of things with their slugs, especially once we start adding in the database. We will want to fetch things based on a unique value, which is the slug, and not the index. And this is a bit more of a descriptive data structure as well, as opposed to just having nested array of numbers. And one thing that I forgot to add here is we can't update unless we have a user logged in. Because we're using the database, we need to associate all of our course progress with a specific user. And that means requiring a user to be logged in. So we need to put a VIF here to first check if we have a user logged in. And if not, we just don't show the lesson completion button. So in this lesson, we have begun to lay the groundwork to refactor our app from keeping course progress in local storage to storing it in the database and then using Pinia as a client-side store. In the next lesson, we're going to take a slight detour and actually fix a small regression that I introduced in the previous chapter on the meta endpoint. But then we will resume with putting together our Pinia store with the database. In this lesson, we need to fix up the meta endpoint because when we refactored it to use Prisma, I accidentally introduced a regression. Now, this is one of the downsides of not having any unit tests in a project, and that if I had written good tests, we would have caught that problem immediately. The problem that I am talking about is that we do not add the lesson path to this object here that we return for the course outline. And so that means that we have no lesson path here in our UI. So all of these links here are broken because we don't have a path. We have no URL that we're setting on the links here. And so they just render as regular text. So the fix that we're going to do is to update our types first to add in that path as a string property. And then we'll update the code for the event handler itself. We'll add in some similar logic that we had before in order to fix this. So the one tricky thing that we've got going on here is that our endpoint returns this course outline type, but this course outline type does not directly use this lesson outline type. And so we can add in the path to this type like we did before with the lesson with path type. But because the chapter outline here is based on the lesson select type and not the lesson outline type, that change is not going to cascade through these different types. So we have to have another way of adding that type in. So first, let's fix up this type here. We'll add in this path string here. And so now our lesson outline type is the exact type that we would expect. But we have to do something different to fix up the chapter outline and then the course outline types. So what we're going to do is use the omit utility type. This is something that's built into TypeScript. And what we can do with it is we pass in a type, and then we can provide it with a string or a list of strings describing the properties that we want it to remove. So this is a way for us to copy types. So you can see here in the example for the docs, we take the to-do type, but remove the description. So we had a description here as a string, but then this new to-do, which is a to-do preview, has no description. So we're going to do the same thing here. So what we're doing here is we're saying that we're going to get this type that we had previously, but then we're going to remove the lessons property off of it because the lessons property is based off of this lesson select, which does not have the path property that we want. Instead, we're going to re-add that lessons property in, but we're going to make it a type of lesson outline, which is the correct type that has that path string. So then now this type is the correct one. And then we just need to repeat the same thing for our course outline. We're going to get that type that we had before, but then we'll remove the chapters because it's based on the chapter select type, which is not going to include the path on the lesson. And instead, we want it to use this chapter outline here. So now that we have our types sorted out, it's now time to update the logic for our endpoint. So this is the logic here. It's not any different than anything you've seen before. We're getting the course like we did before, doing some error handling, and then we're going to map through the outline and then add the path on to each lesson based on the chapter slug and the lesson slug. And then finally, we return the outline with this new chapters and the lessons there. We can save that, and if we go to our hopscotch, come to our metadata, and we can see that now we are getting that path on every single lesson. So now that we have fixed the meta endpoint, we can now get back to adding Pina with the course progress saved in the database. And our next lesson will be updating our Prisma schema to add in a model so we can save that course progress to the database. We will update the Prisma schema with a lesson progress model so we can track our course progress in the database. So the first thing that we're going to do is to grab a lesson progress model here, and we'll paste this in. And then I'll explain to you exactly what's going on here. So this model is very similar to the ones that we've already seen in that we have an ID at the top to give it a unique identifier. Then we have a created at, updated at times, but the real value here is that we have this completed field. We use this completed field in conjunction with the user email to determine and keep track of which users have completed which lessons. And this is all that we need to keep track of. We don't need to keep track of which chapters have been completed or which courses have been completed, because if we know which lessons have been completed, we can use the other data we have in the database to determine which lessons are part of which chapters and which chapters are part of which courses. And from that we can calculate which chapters are completed and which courses are completed. So in order to do that, we need to link each lesson progress model or each lesson progress object with a lesson object. And so we do that with this relation here, where we link the lesson ID field in our lesson progress model, which references the ID in our lesson. Now, this is giving me an error here because we don't have the corresponding relation in the lesson object or in the lesson model. But if I save, then the Prisma extension will add that in for us. So I hit save and it adds in this lesson progress array here. And this shows us that each lesson can map to, or each lesson has multiple lesson progress objects, one for every single user. One other thing that we need to add to this model, which we haven't done yet with Prisma, is to add a unique attribute. And this attribute says that every single combination of lesson ID and user email should be unique. And so this will tell the database that every single row has to be unique, and it will not actually let us add in duplicate rows. And this is because we don't want duplicates. Each user can only complete or not complete each lesson once. It doesn't make sense to have duplicates there. And where this really becomes important is that when we go to write our endpoint that updates this data, we need to be able to find a specific record. And we can only do that if there is a guaranteed unique field. Now, we can't guarantee that the user email is unique by itself because each user will complete multiple lessons. We can't guarantee that this lesson ID will be unique on its own, again, because there are multiple lessons. But the combination of them is unique. And so that's where we're able to add these in together. In the later lesson where we actually write this endpoint, you'll see this come into play, where we use the fact that this is unique in order to select a specific row. So now that we've got our schema updated with this lesson progress model, the next step is to update our database. So that requires us to come over to Prisma here. We'll run Prisma migrate dev, which will update our client object, then create the migration, and then run the migration against our database. We'll give it a name that's descriptive. And away we go. If we go over to our Supabase instance, we should see that it's updated in the table, or that it's updated by adding a table. So here we go. We've got our lesson progress table that's added in. Currently, this is completely empty, but that will change in the next lesson once we add in that endpoint. We're going to add in the endpoint so we can actually update our course progress in the database. The first thing that we need to do is actually create the file to hold the endpoint. So we'll do this in server/API. I'll create a new file, and I'm going to paste in the whole path here, which is course/chapter, chapter slug, lesson, lesson slug, then progress. So this matches the route pattern that we've been using throughout this course, but then we're going to add on a /progress on the end so that we can address a specific lesson, but specifically the progress for that specific lesson. So when I hit enter, then VS Code automatically creates whatever folders that we need, and we've got our endpoint file here. Now, a lot of this endpoint is stuff that we have already seen, that we're familiar with, so I'm not going to take too much time. I'll just point out and explain the more interesting bits so we can see what's going on. So starting at the top here, the first thing that we do is actually use this assert method utility from H3. And what this does is we can give it an array of HTTP methods that we want to allow. We can put the method in the file name like we did before. So progress.get.ts, for example. But the problem is that we want this endpoint to work with a put, a patch, or a post. And so because we want to use it with multiple, we have to leave that suffix in the file name off. And then we can use this assert method here to prevent any other HTTP methods from coming through. I'll create a hopscotch route for this so we can see it in action. So I'll go to lesson, get first lesson. I'll duplicate this one because it's basically the same as what we want. We'll just remove this. Hit save. And then in the URL here, we're going to append progress and hit save. Now, if we hit send, we get back a 405 HTTP method is not allowed. And that's because we have this assert method here. We also have this protect route thrown in here because if we don't have a user, we have no user to associate the data with. And so this endpoint is useless. So we're going to protect the route to make sure that this can only be executed when we have a logged in user. Now, the rest of the logic is that we first have to grab the relevant lesson. And this is so that we can use the lesson ID off of that object. So first we find the lesson that we're working with, then do some error handling, and down here is where the real interesting stuff is. And so what we're doing here is first we're going to grab the completed field from the body of our request. So this is another H3 method. And if we pass in with our HTTP request a completed in the JSON, this will pull it out. And then we can also grab the user email from the user that's been logged in. And then we can use that in our request. So what we're doing with Prisma is we're using this method called upsert. This does either does an update or an insert, depending on if the record exists or not. So it actually has three different parts. We have a where we have to specify what record we're looking for, an update to specify what fields we're going to update, and then a create so that if the record does not yet exist, we know what to do in order to create it. In the where section here, you'll see that we've got this interesting little underscore thing here. And this is auto-generated by Prisma. And it's based off of this unique attribute that we added in the previous lesson. You'll notice it's lesson ID underscore user email. If we don't provide this, we cannot do an upsert because we cannot find a specific record. This is why we have to, when we're looking for the lesson, we have to use the find first method and not just a find unique method. Because with the lesson object, we never specified that any of the lessons are going to be unique. We could definitely do this with our lessons. We could say that the combination of chapter ID and lesson slug are guaranteed to be unique because in the course so far, we have treated them as such. We've never stated that there could be multiple lessons of the same slug in the same chapter. And in fact, the logic in our application assumes that they are unique. So in fact, we could put this in here. We just haven't done that yet. And so when we go back to our code here, we have to do a find first on here, and we could not do an upsert because Prisma does not know that this lesson object is guaranteed to be unique. Whereas over here, because we've added in that unique attribute, Prisma knows, our database knows, that these lesson progress objects can be unique. And it's based on this specific pairing of properties. And so then we're able to pass in those properties from the lesson that we just fetched, as well as the user email we got from our logged in user. Then if the record already exists, we just update the completed field. If not, we use the completed field to set it initially. We add in the user email, and then we have to connect it to an existing lesson. Now we have to do this because we have that relation in our schema. And this makes sure that the connections between the two objects are going to stay in sync correctly. So once we've done all of that, our lesson progress record has been updated or created, and we are good to go. So now that we have this endpoint set up, we're going to update our Pina store to use this. So we'll come down to our toggle complete method here. And here we have a to-do to update in the database. So this is where we'll add in our API call now. What we're going to do is a try catch. So we're going to do a fetch that will post the data. We actually don't need this because we're pulling that user email from the logged in user. And if that fetch fails for whatever reason, then we're going to revert the optimistic update that we did. Because remember, with our toggle complete method here, we're going to first update the UI, assuming that this request is going to work. And then if it doesn't, we have to revert that change in the 1% or fewer of times where the request doesn't go through correctly, then we can revert it. So one interesting thing to note here is that when we're using this fetch method here, we don't have to stringify the body like we would normally have to if we use the native fetch. And so that's just one nice little convenience thing that I wanted to point out. Okay, so now that we have this hooked up, let's go over to the application and see it working. So one thing that I need to do is first remove the local storage. So we're just going to create this as a ref. And we need to specify that this is any, just to get rid of some errors quickly. We'll refresh our page completely. And this toggle complete button is not showing up. So what are we doing wrong here? Oh, we're checking if user exists, but we're not actually grabbing or creating this user value. That's what's going on. So if I update that there, then if I hit mark as complete, if we go to our Supabase instance, go to the table editor, we'll go to lesson progress, and we'll see that we've got this value added in. If I come to chapter 2 and hit mark as complete, we hit refresh in our database, we'll see that come through as well. There we go. Now we've got that second one in there. Great. So in this lesson, we added in the endpoint to actually update our course model or our course progress in the database. And then we hooked it up with the toggle complete method in our Pina store so that now we're tracking progress of the user in the database. But right now, we're not actually pulling that data when the page is being refreshed. So that's the last missing piece to get this whole thing working. We're writing to the database, but we're no longer, or we're not reading from it yet. And that is what we will do in the next lesson. In this lesson, we will be adding in the endpoint where we can fetch all of the course progress for a specific user. And so we'll be able to use this in our application to load up that initial state into our Pina store so that we know which lessons the user has completed and which they haven't. So first we need to figure out, what do we want this endpoint to do? In our database, we've got a bunch of different records that show us which lessons the user has completed. But we don't want to return that specifically to the UI because that raw data isn't as useful to us. It doesn't tell us how much of the course they haven't completed, although it is useful for telling us which ones they have. And if all we wanted to do was use this mark complete button, that would be fine because we could show if they've completed it. And if we don't have that data, we'll just assume that it's false. However, in the next lesson, we want to add in a feature to show the percentage completion of each chapter, as well as the percentage completion of the course as a whole. And so we need to know how many courses, how many lessons they have yet to go. And we want to be able to do this in an easy way. And in theory, we have all the data in the front end that we need to calculate this. We've got the course outline and we've got the progress data. We can combine this together on the front end, but we're going to combine it on the back end instead because we'll be able to create an endpoint that's more useful in other places if we wanted to get this data. It is a bit of a judgment decision here on whether we do that logic in the client or on the back end, but for now we're going to do it in the back end. So first we need to create our API endpoint, and we'll create one at API/user/progress because we're going to get all of the progress for a specific user. And we're going to tackle this in a few steps because it does get a bit complicated. So we're first going to protect this route because we can't get user progress if there's no user logged in, of course. And then we're going to find all of the lesson progress objects that match this user's email and are for this specific course. So we're building in the functionality to eventually add in more courses, but for right now, we're going to hard code in this course ID since we only have the one. And we'll add in this nested select here to grab the slugs for the lesson as well as the chapter. Then the next thing that we're going to do is fetch the course outline so that we can then combine all of the lesson progress data with the course outline, and we can get a whole overview of how far this user has come in completing the course. So to do this, we use our $fetch that we use on the client side, but because it's isomorphic, we're able to also call this on the client or on the server side. So we'll make use of our course meta endpoint that we've already created, and we'll fetch that course outline. But keep in mind that because of the optimizations that Nuxt does, instead of making an actual HTTP request, it can directly call that method instead of going through all of those HTTP layers. So this call, because it's an internal call, is more efficient. Our next step, now that we have these two sets of data, is to marry them together to create our full progress outline. First, we need to create some types that we will use in the course. Our first step in combining these two data sets together is to create some types that we will need. So we'll open up our custom types here, where we only have one for now. We'll paste in this chapter progress and course progress type. So this syntax, all that it's saying is that we're going to have an object where all of the keys are going to be strings and all of the values are going to be Boolean. So we're not really dictating the shape of this, other than that it's an object. And then for the course progress, we're doing a similar thing, but we're saying that for every value, it's going to be a chapter progress type. So this describes the nested structure of our course progress, where the top level keys for the object will be the chapter slugs. And then within that, we're going to use the lesson slugs to access the Boolean values, whether that lesson is completed or not. So now that we have these types, we can go back to our endpoint and we'll import those types along with the existing types we have from our meta endpoint. Then I'm going to come down here and paste in the logic to combine everything. And so what we're doing is we're creating that nested object that we just described with our types. We go through each lesson and we're going to make sure that we find the lesson that matches the given slug for the chapter and the given lesson slug. And if we can't find a lesson progress, then we will just default to false. So that means we get each chapter specified with either the value found in the database or false. And then we do that for every single chapter in the course. And then we have our full object, which we then return at the end of the event handler. And now that we have this course progress type, we can update our Pinia store to use the type. We can go from this any type to course progress. We can also now add in to our initialize function the code we need to fetch all that initial data. So we'll get rid of this comment and then we'll paste in this code here. And what we're doing is stuff that we've seen before. We're going to use the useFetch composable to hit our progress endpoint, but we're going to make sure to pass in the cookies along with that so that we can pass in our logged in state. And then once we get this user progress data, we're going to update the progress here of this ref. Now we use this pattern of first initializing the ref without any data and then updating that so that we can take this ref and pass it back to our components. So now that we've got all this stuff going here, let's refresh our page so that we get it in action. So why don't I create an entirely new session just to make sure that we're not caching any data or anything like that. If I hit that endpoint, then we can see that loads and it shows that this lesson has been completed, as well as the very first lesson in the course. But if I go to our database now and I update these directly in the database, let me set these to false. I'll make sure our session storage is not caching it. Well, I guess it wouldn't because we're not using the useFetch with cache. Here, we're just using straight up useFetch, which is done intentionally because we don't want to cache that data. And you'll see that if I load this now, these two lessons are loading the correct data from the database. Of course, I can switch them back just by clicking on the UI, as you would expect. And there you see that we have now changed them back. So now we have complete end-to-end from the UI, writing to the database, and then retrieving from the database back into our Pinia store. We've seen how to use Pinia to keep track of our course progress, how to use this initialize pattern to initialize asynchronous data in our store, and how to use this toggle complete along with this optimistic update, which we can roll back if the request fails. And in the next lesson, we'll see how we can add on to this to show the course completion percentages in the UI to give a bit of a better feedback to the user as to how far along they are. In this lesson, we are going to add the percentage completion feature so that as our user is going through this course, they'll be able to get that feedback in the UI here on how far they've completed each individual chapter, as well as how far along we've come in the course. So we're already storing everything in the database as far as course progress is concerned, and we're keeping track of it in our Pinia state here as well. So I've decided to calculate this percentage in our Pinia store as opposed to on the server when we fetch the course progress in this endpoint. You could make the argument to put that calculation instead in this progress endpoint, but to me it feels a bit more like a UI feature, and this chapter is all about Pinia after all, and so I wanted to add in a bit of extra logic and functionality here so that we can work with Pinia just a little bit more. So to start, we're going to add a computed property called percentage completed. So we'll come to the bottom of our Pinia store and we'll add it in. So what we're doing here is we're grabbing the information that we have from the progress object, and we're going to grab the chapters. We're going to, for every single chapter, look at the total as well as the completed lessons. And then we're just going to do a pretty straightforward calculation here to grab the percentage. We're going to use this number so that we can get a fixed number of decimal places. So what this toFixed method does is basically what we're doing is getting the percentage, which will be a number between 0 and 1. We multiply by 100. And then since we do not want any decimal places in our UI, we just want the rounded number, we can call this toFixed method with an argument of 0 to show that we want 0 digits after the decimal place. And so that's a convenient way to clean up those numbers for us. So we get this object, or this array rather, of all of the percentage completions for our chapters. The next step is to do a similar thing, but for the course as a whole. So we're going to return not just the chapters, but also the value for the course. And so we're doing similar logic here, but we're splitting it up a bit. So we're going to grab, for every single chapter, we're just going to add up all of the lessons in the different chapters. Then we're going to go through and add up all of the completed lessons in all of the chapters. And now that we have the total completed lessons for the entire course, as well as the total lessons in the course, we can do the same calculation, get our percentage, format it nicely, and then return it in this object. So the last thing we need to do is to actually return this percentage completed so that we can use it in our component. Now, once that's done, we can come over to our course component here. Because we want to add this information into our navbar here, this navbar lives in our course here, this course component. So first we have to import the Pina store and then access that data from the store. So we'll import use course progress. We're also going to import store to refs because we want to destructure the percentage completed array or object off of the store without losing that reactivity. We're also going to grab the user because we only have this percentage completed information if we have a user that's logged in. So we need to check to see if we do have a user. And if we don't, then we can hide this information. Otherwise, we would have to show 0% or some other sort of thing, and that just kind of shows a wonky UI. So we're going to check first if we actually have a user logged in and if we actually have data to calculate that percentage. And then once we've done that, we can use store to refs and then destructure to get the percentage object. To update our template, we're going to come up here to our H4 where we have the chapter title. And we're going to replace it with some markdown here, or markup actually. We're going to have the title, but then we're going to add in the percentage completed beside the chapter title. And you can see here that we're checking to see if we actually have percentage object and we have a user logged in. So if we don't have both of those, it doesn't make sense to show this information. So we're not going to. Now we're grabbing the correct percentage completed number based on the index here. So we need to add that into our v4. And so we can do that by just wrapping this in some brackets here. And similar to a for each loop, we can also get the index that we're currently on. And so that way we're able to index into this array. Now, I actually debated whether or not we should, instead of using an index, use the chapter slug and make this chapters array into an object. And it would complicate the implementation just a little bit, but it might make it a bit more reliable and more robust. But I think it's probably fine the way this is right here with the index and using an array. And so I just decided to keep it this way. Now we also want to show the overall course progress. And so we're going to do that at the bottom of the nav here. I'm not sure if that's a great UI choice, but it's the one that I made. And so we're sticking with it. So we'll come down to the bottom of the nav here and we'll copy in this code here. We don't actually need this formatting because we're doing it in the Pina store itself. And the formatting here got all messed up. There we go. Now it looks like I need to restart our dev server before we'll pick up the changes. And there we go. Now we can see that we've got our course completion percentages beside them, beside the chapter names. And then at the very bottom, we have the overall course completion. And this is fully reactive. And so if we look at, we're in chapter 2. So if we look at this chapter 2 completion, if I toggle this back and forth, we can see that that updates. As well, the overall course completion will update reactively because we're updating in the store. And because we're doing the optimistic UI updating in our Pinia store with the toggle complete method here, because we're updating it first before we even make that API call to the database, this calculation is done instantaneously. And if for whatever reason we hit that very, very small chance that it doesn't actually change in the database, it will automatically roll back. It will revert that for us. So if we do hit this button and our progress updates to show now we're at 75% completed, if that call did not actually go through, it would revert, which would toggle this back on to complete, and then also recalculate this to 100% again. So in this lesson, we took a quick look at how we can add on a bit of extra functionality and calculate the percentage completion of our course with a fairly straightforward computed prop that will go through and calculate the percentage of each chapter as well as the course overall. And because this calculation is done as a computed prop, it's going to be reactive, which means that no matter what happens with our database calls or how we update the progress, it will always stay in sync and will always recompute to be 100% accurate. In this chapter, we saw how we can use Pinia as a state management tool for our apps in Nuxt. We refactored our app to use Pinia to store the course progress state instead of using local storage. And we also refactored it so we can store that state in our database in Supabase. We also had to fix up the meta endpoint a little bit because I added in a regression by accident. And then at the end, we added in a percentage completion feature so that we can see in the UI just how far we are in each chapter, as well as the course overall.